Evaluate integral from 0 to 3 x to the power 3 over 3 minus x to the power half dx. So looking at this problem, you will see that this problem has the properties of beta functions. And the general definition for beta functions is integral from 0 to 1 m to the power x to the power n minus 1 into bracket 1 minus x to the power n minus 1 dx equal beta of mn. So if you look at the problem very well, you will know which properties is the problem exhibiting. If it were to be gamma properties, you will see a term, or you will definitely see a hint about a term that can be in this form. So this problem, before we can apply this idea here, we have to make sure that we have a term like this, and generally also a term like this. So let's rewrite this question right here. So rewriting this question right here, we can see this one is the same as integral from 0 to 3. And for beta functions, the limit is from 0 to 1, right? But because it has properties of beta functions, after we are done with our substitutions, we are going to see a change in the length. So x to the power 3 right here, crossing this, bringing this up here will make the power here to be minus. So we have 3 minus x to the exponent minus half dx. So now, this problem should be of the form 1 minus x. And now that we have 3 minus x here, we have to massage this to look like something like this. So in doing so, what I recommend doing is that just bring this term right here out, right? You open your bracket, then bring 1 here, you write 1 here, and you write minus x here, and you close your bracket, right? So look at the exponent. If it has 1, here we have an exponent minus half. So this 3 right here, this 3 out here is also affected by the minus half. So you bring minus half. And looking at this, if you should look at this, if you multiply 3 by this, you get 3, which is right. But if you multiply 3 by this, you get 3x. So in order to solve that problem, divide whatever is here by what you brought out. Good. So now, if you multiply 3 alone, because they all has a power minus half, if you multiply 3 by here, you are going to get 3. And if you multiply 3 by all of this, 3 will cancel 3 here, remaining minus x. So nothing changed. You are just arranging it in a form that you can make your substitution. And before you make your substitution, make sure it's of the form 1 minus something, right? So now we have 1 minus x to the power x on 3, sorry. So we can do substitution. We can substitute a certain variable, right? We can replace this one by a variable and work on it. So now from the problem, we have integral from 0 to 3. We have x to the power 3. Bring 3 out, and don't forget about the power. Then everything here, then 1 minus x. And to take care of this here, you divide by whatever you send out, but not with the power, because this one is already having the power, so nothing changed. So now what we are going to do next is to substitute this term here with a value. So in doing so, we are going to say let our u equal x on 3, not negative x on 3, because from the general definition, the negative there is very significant. So now we have to look for the x. We also have to look for x, so that we were able to substitute everything, so that at the end of the day, we get this whole term to be in use. All the variables to be used. So making x the subject here, if we wish to cross multiply by 3, we are going to get 3u equal x. So that is the value for x. Keep it in mind. And what we should do next is looking for our dx. Yes. And looking for the x, we are going to use this term here. So we have x equal 3u, right? So the x equal 3 du. It's just like saying we have x equal 3u. So we are going to differentiate the x with respect to u, right? So this is going to give us, so we are differentiating with respect to u. So 3. So this du here, if you to make the x the subject to be 3 du right here, so nothing changed. Now we know the x, we have to look for our limit. Because we are doing substitution, our limit might be affected. So we have u equal x on 3, right? So when x equal 0, what will happen to our limit? So when x equals 0, our u equal 0 on 3, which is actually 0. So when x equal 3, what happens to our limit? So x equal 3, u equal 3 on 3, which is 1, right? So now you can see that our limit has set. Like our limit now is now okay. So it means it will start from 0 to 1, which goes with the general definition for beta functions. So now that we are done converting everything, so we have our integral from 0 to 1 of x cubed, and now we already worked for the value of x, and we said x right here equal 3u. So we are writing 3u here instead of x. So 3u but to the power 3, all to the power 3. Mind you, we are using our last expression. This is how this is how we express the problem too. How we break the problem. So our x to the power cube, our x is 3u to the power cube, and we have 3 to the power half, right? And it's actually minus, or into bracket 1 minus x on 3. We said x on 3 should be u. So u, don't forget that, all to the power minus half dx. But how do we say our dx is? Our dx is 3 du. So 3 du. So now we are going to simplify this further. So this one is actually integral from 0 to 1. This 3 is affected by the power 3. So 3 power 3, the same as u. So u power 3. And we have 3 to the power minus 1 on 2. This term, we are not going to affect it because we need it to be in that form. So 1 minus u all to the power minus 2. We have 3 du here. So let's group all our constant terms, all the numbers. We are going to have, actually let's bring them out of integral sign. So we are going to have 3 to the power 3 and 3 to the power minus half. They are actually multiplying, and 3 here. And we bring our integral sign from 0 to 1. We are left with u to the power 3. Can you see that? And what else? And this term. So 1 minus u to the power half du. So let's continue. So you can see that from indices we can simplify this. We have 3 to the power 3 and 3 to the power negative 1 and 2 and 3 to the power 1, right? Since they have the same base, you can definitely add the powers. So adding the powers, you can have 3 to the power 3 plus minus half, which is the same as half plus 1. Integral from 0 to 1, u to the power 3 to bracket 1 minus u all to the power minus half du. So punching this on calculator will give us 3 to the power 7 on 2, integral from 0 to 1, u to the power 3, 1 minus u to the power minus half du. So looking at this term right here, simplifying this on your calculator, 3 to the power 3 minus half plus 1 means 7 on 2. So we have 7 on 2, integral from 0 to 1, 3 u to the power 3, 1 minus u all to the power minus half du. So comparing it to the general definition for beta functions, now beta of mn equals 0 integral from 0 to 1 x to the power n minus 1 to bracket 1 minus x to the n minus 1 dx. So now we are going to compare powers and equate the corresponding powers. We have 1 minus x here, and we have 1 minus u here, which is like more like the same thing. So you equate n minus 1 to minus half. So n minus 1 to minus half. And solve for n, multiplying 2 by 2, we have 2n minus 2 equal minus 1. So this minus 2 quotient become positive 1, and then 2 quotient become positive 2, and minus 1 giving us positive 1. Dividing 2 by 2 give us n should be equal to half, positive half. So now m here, we equate the powers of this term, u to the power 3 and x to the power m minus 1. So m minus 1 equal 3, solving for m gives us 4. So the solution for this problem, 3 to the power 7 on 2, integral from 0 to 1, u to the power 3, 1 minus u to the power minus half du equal 3 to the power 7 on 2 beta, let me write it here, equal 3 to the power 7 on 2 beta of mn, which is 4 half. So evaluating this, the value that we will get for this will be the solution of the whole of this problem. And using the relation between gamma and beta function, we know beta of mn equal gamma of m, gamma of n, all divided by gamma of m plus n. So let's do same. We are going to get 3 to the power 7 on 2. Don't forget this. Gamma of 4, gamma of half, all on gamma of 4 plus half. And 4 plus half is going to give us 9 on 2, right? So let's keep this for now. Let's solve gamma of 4, gamma of half, gamma of 9 on 2. Gamma of half is a constant, the square root of pi. And for gamma of 4, to simplify gamma of 4, we're going to write it in a form gamma of 3 plus 1, which will be equal to gamma of 3 factorial, right? If it were to be gamma of 5, then we write it in a form 4 plus 1, gamma of 4 plus 1, which will be gamma of 4 factorial. 7 will be 6 plus 1, gamma of 6 plus 1 equals 6 factorial. So this is going to be gamma of 4 is going to be 3 factorial. So 3 factorial square root of pi. All on, what about gamma of 9 on 2? For gamma of 9 on 2, we are trying to express it in a term like something plus 1 to give us 9 on 2, so that we can apply this formula like gamma of n plus 1 equal n gamma n, since it is a fraction. So let's say n plus n, we want something plus 1 to give us 9. So n plus 1 should equal to 9 on 2. So solving this, you will see the value, you will get the value of n to be 7 on 2. So 7 on 2 means that you can go ahead, you can say gamma of 7 on 2 plus 1 equal 7 on 2 gamma 7 on 2. So you do that as your term when we decide, when you are looking for a certain number that will add 1 to get what you want to find gamma of is giving you a negative, then you can stop at that point. Or if you get half, it will be square root of pi. So let's continue. Let me write this here. So we've gotten to a point 3 factorial square root of pi, all on gamma of 9 on 2. Then we just simplify it to got 7 on 2, right? 7 on 2, which is here 7 on 2, gamma 7 on 2. And the simple way, 3 factorial is 3 by 2, right? Which is 6. So 6 root pi. And the simple way I used to do this is just use your calculator. You have to find the gamma of 9 on 2. Let's start from 9 on 2. So 9 on 2. Start subtracting 1 from it, right? Let's assume we are starting from. So start subtracting 1 from it, minus 1. Whatever you get is 7 on 2. You got 7 on 2. So write that 1, multiply. So minus 1, 5 on 2, right? Multiplying. Minus 1, 3 on 2, right? Minus 1, 1 on 2, minus 1. You see, now we are getting negative number. Then stop there. Stop right there. You stop at 1 on 2. So just bring gamma 1 on 2. So now multiply everything here. And gamma 1 on 2 is a constant, right? So this is going to give us 6 square root of pi over 105 all on 16 square root of pi. So, but don't forget that this is actually multiplying 3 to the power 7 on 2. So to be at the safer side, 3 to the power 7 on 2 is here. So what I'm going to do is that I'm going to turn this thing right here, or let's take just the numeric expression. We have 6 on 105 or on 16, right? So this will give me 6 multiplied by 16 on 105, right? So simplifying this will give me 96 on 105. So what 96 on 105. So I can actually write the whole of this term like this, to the power 7 on 2 multiplying 96 over 105 square root of pi over square root of pi. So if we multiply this by the, you can focus on the numeric expression. So 3 to the power 7 on 2 on 96 over 105, you will be getting, the decimal number 4.27569 multiplying square root of pi over square root of pi. So this will be the final answer for this problem.